The format of an exponential function, right, is as shown. F of x is equal to a times b to the x. F of x can be replaced with the y, right? So if we don't want to see f of x as it confuses us, we could write y is equal to a times b to the x. The a represents the y-intercept and the initial amount of y. B is your growth or decay factor, right? It's called a factor because you're multiplying repeatedly by b. If b is greater than 1, it's a growth. If b is between 0 and 1, it's a decay. Let me show you two examples, right? Let's say you have y is equal to 5 times, right? Is that a growth or decay? It's a growth. What's the initial amount? 5, right? Because a is the initial amount. And then if I had this,
decay,
right? Because b is between 0 and 1. You can look at it as it just being less than 1. But the reason they put between 0 and 1 is because it can't be a negative, right? Cool. So that's a decay, and our initial amount is 7. Now, the next thing is understanding a little bit about percentages, right? Look at this example. In 2012, Monica deposited $500 into her savings account that earned her 12% compounded annually, right? And what that means is that each year she's going to get 12% of what's in that account and add it back to the total amount in her account. This kind of problem is exponential. In fact, most problems that tell you something is growing by a certain percentage, the majority of them will be exponential. That's a cool trick for this test to help you know that. Right? So if we make an equation for this, we're going to get y is equal to, what's a going to be? Remember, that's the format. What did I say a represented? It's the initial amount. So what's her initial amount in the account? 500. Now, B is trickier, right? So based on the question, is this a growth or decay? Right? She's earning. So B, in order to find B, given a percentage, for a growth, you're going to do 1 plus R. So hold on. B will be equal to 1 plus R. R is your percentage converted into a decimal. So it'll be 1 plus what? All raised to the x. And look, this is how an exponential function looks, right? It looks like a curved line. It's not a straight line. We're going to compare it to linear functions in a second. So this should make sense now. The 1 plus R. Now, if it's a decay, it's really easy to remember. It's just going to be 1 minus R. Here, for example. So at the end of 2007, the value of Angelica's car was $26,000. Starting in 2008, the value of her car depreciates at a rate of 26%. This is obviously wrong. Hold on. That's not 500. That's 26. Right? So A is the initial amount, is 26,000, but it's in thousands. That's why I only put 26. What we could do is this. I'm going to rewrite it. So the initial amount would be 26,000. And then in this case, you do 1 minus 0.26 because it's a decay. Cool? Take a look at this, guys. So whenever you have 100% of something, it stays the same, right? Like when you multiply by 100%, and remember, we haven't gone over percent yet, but percent means divided by 100, like per 100, correct? So 100% is the same thing as 100 over 100, which is equal to 1. Like having 100% is like having the entire one of it, right? One whole. Does that make sense? So having 100% of something means that it doesn't change. It remains the same. Now, I want to kind of like explain a little bit more where like the 1 plus and 1 minus comes from. So if I increase by 25% from 100, technically you could say that I'm at 125%, right? And if you convert that to a decimal, wouldn't that give you 1 point, right? 125% is the same as 125 divided by 100, which is the same thing as 1.25, right? And that should connect to the whole 1 plus R thing, right? The R, if you're increasing by 25%, is 0.25, and 1 plus 0.25 is 1.25, right? It's the same thing. Now, what happens if you reduce by 25%? Like if, and you can apply this to like going to the mall and shopping, right? When something's 25% off. If you think of it as like from 100, if you remove 25%, what are you left with? 75, right? And as a decimal, that's 0.75. So the key here is this. Let's say that something cost X dollars, right? And I multiply by 0.60. First thing I'm going to ask you is that a growth or decay? Am I gaining or losing? You're losing, right? But then the next question is, how much did I lose? Right? Don't get it twisted. You didn't lose 60. When you multiply by 0.6, you're keeping 60%. What you're losing is related to 100, right? 100 is your baseline. Right? At 100%, you're not gaining or losing. You're staying the same. Like you have the whole thing, right? Like the shoe you're going to buy, if it costs 100% of its value, is going to cost the full amount, right?
Mm-hmm.
If it's 25% off, how much of the shoe, how much of the 100% are you left with?
75.
That's how that works. It's always based on 100. So from 100, if you lose, you subtract. If you gain, you add.
Uh-huh.